Next topic is armature reaction in synchronous generator. First we discuss about the armature reaction in cylindrical rotor synchronous generator. Then we move towards the electrical equivalent model and then power angle equation. So first observe armature reaction in synchronous generator when a generator is operating at different power factor. So armature reaction in synchronous generator. Armature reaction in cylindrical rotor synchronous generator operating at different power factor. Let us first discuss about the generator is operating at unity power factor. So at unity power factor load. When I am saying unity power factor load, it means the load connected at the terminals of the generator is of unity power factor. So you can say a resistive load is connected at the terminals of the generator. Now please observe, we have this to be the generator. Presently I am representing the concentrated winding so that it will be very easy to understand armature reaction concept. Okay. So now please observe, we have this as a generator with A dash, then 120 degree apart is your B dash phase and 120 degree apart is C dash phase. Now please see, A dash, B dash, C dash are shorted as we have discussed in the armature winding, and A, B and C, three wires are coming out and a load is connected across these, that is load, and this load is of unity power factor. Is it okay? Now please see, we have a rotor and DC is provided to this rotor. So because of the DC current, fixed polarity of poles are being formed, and if the rotor is rotated, the poles are rotating in space. Is it okay? This rotating flux cuts the stator conductors and induces EMF in the stator conductor, and that induced EMF drives a current for the load. Now please observe, let us suppose this north is at this position. So the induced EMF in A will be started, and when the north reaches to this position, the induced EMF in A will be maximum. Is it okay? So if we observe that this particular instantaneous position of the pole, we found that the induced EMF in A dash will be maximum. Let us suppose we are rotating the rotor in an anti-clockwise direction. So the polarity of induced EMF is, you can say whenever the field is rotating, stop the field and rotate the conductor in opposite direction. So these conductors are under the influence of north, so they will induces EMF in such a way that it can be, the polarity of induced EMF can be marked in terms of current flowing into the conductor. Similarly, if you observe this, in the magnetic line of forces are going in this fashion, so you are stop the field and rotate the conductor in opposite direction. So if you are rotating the conductor in this direction, means these conductors are rotated in this direction, so they will have the polarity of induced EMF in terms of current as inward. Is it okay? Now these induced EMF causes current to flow, and that current is being supplied to this load since the circuit is completed. This load is of unity power factor. When I am saying unity power factor, it means the voltage and current are in same phase. Is it okay? Now please observe, at this particular instant IA is flowing in this fashion as coming out, while IC and IB are flowing in this fashion. So you can say, sir, as the position changes, this direction of currents are going to be changed and the magnitude of currents are going to be changed. Now please observe, if the load is connected, the current is flowing into the stator, and we know that a current carrying conductor will produces a field, and the direction of field is found by right hand curl rule. So by the right hand curl rule, you can say if the direction of current is thumb, then right hand curl is representing the direction of field. So the direction of field formed because of the current flowing in stator can be represented by the two magnetic line of forces, and that I have represented in this fashion. Now if you observe the magnetic line of forces produced by the current flowing into the conductor are in this fashion. As the current is inward, so the fluxes are going to be completing their path in this manner as I have indicated in the terms of arrow. So you can say this terminal is acting as a north for the stator and this terminal is acting as a south for the rotor. We also observed in the previous lecture that as the rotor rotates, these fields are also rotating, and the speed of the rotor and the speed of the field, it means the relative speed between the rotor field and stator field is 0. Is it okay? Both the speeds are same, so the relative speed between them is 0 at any instant. Now please observe. This axis is called as main field axis. Is it okay? So that I am representing by FF. And because of the current flowing into the armature, that produces armature field, that I am representing by FAR, that is armature flux. So the armature reaction means the effect of armature flux onto the main field flux. So if you observe, due to the armature flux, the main field flux and armature flux will provide the resultant flux in this manner. So this will be your resultant field. It can be observed that at unity power factor, at the instant when induced EMF comes into the picture, at the same instant the current will be flowing. So you can say, sir, at this point induced EMF is maximum, at the same point current is also maximum. So voltage and current are in same phase. When the current will flows in this fashion, it will produces the flux in this way. So armature reaction at unity power factor is seems to be cross magnetizing. It means it produces the flux that cross magnetizes the main field flux. So armature reaction at unity power factor has cross magnetizing effect, and due to that the resultant air gap field changes its position. Is it okay? Now please observe one more thing. You can say, sir, the resultant magnetic field changes its position. So instead of representing the main field axis to this, because main field axis is very strong, so we represent this south and north changes its position to this new position. Is it okay? And the angle between the stator field, or you can say resultant field, and the main field axis is said to be the load angle, that can be represented as a load angle delta. Is it okay? Now please observe. I will explain this in a more effective way. Please observe. Again, whenever you have to observe the armature reaction, then you can take flux as a reference. So if I am taking flux as a reference, so let us suppose this to be the flux or main field axis FF. If this will be the main field axis FF, then from main field axis, let us suppose flux is phi m cos omega t, then d phi by dt will give you E, that is induced EMF, that is sine. So cos and sine will have 90-degree difference. So always remember that induced EMF in the rotating machine is 90-degree lagging to the field. So if this is the field, I am taking this to be lagging by 90-degree, and that I have represented by a clockwise 90-degree. If field is taken as a reference, then induced EMF is 90-degree lagging to the field. D phi by dt, I have taken field as phi m cos omega t. In rotating machine, the field is always considered to be a cos omega t, and therefore induced EMF will become sin omega t. Now please observe, at unity power factor, I am saying unity means internal power factor to be unity. If the internal power factor is unity, it means the armature current is in phase with the voltage, and sir, the armature MMF produced is equals to armature current into number of turns. If number of turns are constant, whenever we multiply the phasor with a constant, only the magnitude changes, phase angle will remain same. So in the same phase, we get armature reaction flux, that is FAR. So armature reaction MMF and main field MMF will give the resultant MMF, and you can say, sir, we obtain the resultant MMF to be located at this point. This suggests that the resultant MMF shifts in position. Is it okay? And the effect is cross magnetizing. The magnitude of the resultant MMF is almost equals to FF, and we consider this to be the normally excited generator. Is it okay? Now please see, at unity power factor, armature reaction in synchronous generator has cross magnetizing effect, and generator is said to be normally excited. Okay. So at unity power factor, armature reaction in synchronous generator has cross magnetizing effect and the generator is said to be normally excited. Is it okay? Now come to the next point. What I have said, that what is the load angle. Now we have to understand the concept of load angle. Now please observe. You can say, sir, this will we have the stator and this we have the rotor. The rotor will have the north and south here, and we have rotated the rotor in this direction. So we found that this to be the rotor field, and because of this the armature induces EMF, and if this EMF is allowed to drive the current, it means if the circuit is completed through the load, then only the current drives. This induced EMF drives a current. I am considering only one phase as A phase. So you can say IA drives by this induced EMF, and at unity power factor you can say the induced EMF instant and current instants are same. It means induced EMF and current are in the same phase. So when induced EMF is becoming maximum, at the same time this current is maximum. So when this current is maximum, this will become stator north and stator south. This stator north and stator south will create stator MMF, or you can say stator flux. So this will be your rotor flux and stator flux or stator MMF. So you found that the resultant flux will be this, and the effect is cross magnetizing. You can say, sir, it means this north and south will be reaches to this position. It means this north and south will be reaches to this position, and the entire magnetic line of forces are now completing their path in this manner. The entire magnetic line of forces are now completing their path in this manner. Is it okay? So you can say entire magnetic line of forces, if we represent by the two magnetic line of forces, so they are completing their path in this manner. Is it okay? So we are rotating this on this direction, and you can say the magnetic line of forces are completing their path as represented by the dotted one. Is it okay? So you can say, sir, always this north try to align towards this resultant magnetic field, that is south, and the angle between them is defined as the load angle delta. So why I am saying this to be the load angle delta? Because if I am rotating the rotor, then this north always try to align towards the resultant south, and therefore an electromagnetic torque is existing that tries to rotate this north towards this south. Is it okay? So that is why this angle is called as load angle. Further observe, this load angle also justify the load conditions. If I increase the load, it means more load is connected in parallel. It means more impedances are connected in parallel. If the more impedances are connected in parallel, overall impedance is lowered, and therefore this current is increasing. So whenever I am saying electrical load is increasing, it means you can say, sir, current is increasing. Is it okay? So whenever electrical load is increasing, it means current is increasing. If the current is increasing, then this MMF increases to a higher value. So you can say this MMF increases to FAR nu, and this FAR nu and resultant will create this to be the resultant field nu. And you can observe that with the increase in load, this load angle is increases from delta 1 to a new load angle, that is delta 2. Is it okay? Similarly, you can say as the load increases, load angle increases. As the load decreases, it means current decreases, the MMF in stator MMF decreases, so load angle decreases. So load angle is basically the angle between resultant magnetic field and main field. A load angle is the angle between main field or rotor field and resultant air gap field. Is it okay? Now, at unity power factor we observed that the armature reaction has cross magnetizing effect, and the generator at unity power factor is said to be normally excited, as we have said that the magnitude of the resultant field is almost equals to the magnitude of the field. Okay. Now observe what happens when we operate the generator at lagging power factor. Let us take the case of 0 power factor lag. So at 0 power factor lagging, It means if the pure inductive load is connected across the terminals of the generator. Now please observe what happens when the 0 power factor load is connected across the armature. You can say, sir, in this the armature current lags the armature voltage by an angle 90 degree. 0 power factor lag means cos phi is equals to 0. So phi must be equals to 90 degree. So it means the current is lagging by an angle 90 degree. This is only possible when a pure inductive load is connected. Okay, so a 0 power factor load when connected, then you can say, sir, the induced EMF will become maximum when the rotor north reaches to this position. Okay, so in A dash, I am taking A phase as a reference phase for armature reaction. So you can say, sir, when the rotor north reaches just below this stator conductor A, so you can say the induced EMF in the stator conductor A will be maximum. So induced EMF is maximum, but the current flows after 90 degree. It means current is lagging by 90 degree in time. So in time, it means since the voltage induced as a function of time, so you can say in time, if 90 degree, after 90 degree current flows into the conductor A, it means after 90 degree the north will be reaches to this point. Is it okay? In the unity power factor, when this north is just below this conductor, at that time induced EMF in A will be maximum. At the same time current will flows. However, in case of 0 power factor lag, induced EMF is maximum when the pole is at this position, but the current flows when the north reaches to this position. So you can say, sir, whenever you have to find the power factor at 0 power factor lagging, you provide the lead of 90 degree to the field. When it means the stator induced EMF occurs when the north is at this position, but the current flows as per the north polarity to be maximum when the pole position is reaches to this particular point. Is it okay? Because the generated voltage as a function of a time, and I am saying in time current is lagging by the voltage. So you can say as per the north polarity, this is the position of a rotor. As per the north polarity, when this rotor is at this position, the currents are here as outward and here as inward. But that current will be produced when the rotor field reaches up to this position. Since it is not possible to represent the lag and lead in terms of dot and cross, so that is why I have taken an alternative approach and I have provided this rotor itself to be 90 degree ahead, then the current is start flowing into the stator conductor. I am hoping you are able to understand. Repeating it again, please observe. Since the induced EMF is the function of time, you can say since the induced EMF is the function of time or degree of rotation of the rotor. Okay, so if the current flowing through the conductor is 90 degree lagging to the voltage induced in the conductor, then voltage will be induced to be maximum when the conductor is just under the influence of north. However, current flows when the rotor north moved ahead by 90 degree. Therefore, you can say the current in the conductor lags the voltage by 90 degree. So, when this type of current flows, it will created a field, and the direction of field, you can say, sir, again the direction of field will be represented in this manner. If I represent the magnetic line of forces produced by the current flowing into the stator conductor, then by the right hand curl rule, you can represent that this to be the direction of magnetic line of forces to complete their path. So, this terminal is acting as a north and this terminal is acting as a south. You can say, sir, if we observe, this will be the direction of field. Rotor field is in this direction. Main field axis is in this direction, that is rotor field axis. However, armature field is in this direction. So, FAR and FF are oppositely directed, and this suggests that at 0 power factor lagging load, when the alternator is supplying 0 power factor lagging load, then armature reaction is directly demagnetizing in nature. Therefore, overall flux in the air gap of the machine is decreases. Is it okay? So, you can say armature reaction has directly demagnetizing effect at 0 power factor lag. It will be understand in a more convenient way if you take the phasor diagram. I am taking phi as a reference, so you can say phi as a reference or rotor field MMF as a reference. So from rotor field, induced EMF is 90-degree lagging. From this induced EMF, armature current IA is 90-degree lagging. Is it okay? So 90-degree lagging means definitely, sir, from the field EMF is 90-degree lagging, so you have taken clockwise angle for lagging. For leading, we have to represent anti-clockwise. So 90-degree lagging from this, and induced EMF to IA is further 90-degree lagging. So you can represent in this way. Now please observe, you can say, sir, in the phase of IA, armature MMF occurs, because armature MMF is N into IA, where N is the number of stator turns. So number of stator turn is a constant parameter that is not going to change the phase angle. Now you can say, sir, FAR and FFR seems to be oppositely directed. So armature reaction has directly demagnetizing effect in case of zero power factor lagging load connected across the terminals of the alternator, and the resultant field will become this. So you can say the resultant field is lower in magnitude than the applied field. You can say, sir, from our side, that is excited, from our side, that is given onto the rotor, that is rotor number of turns into current flowing through the rotor conductor, that is DC current. So from our side, this FF is the excitation given from our side. It means the flux provided from our side is, that is from the rotor side, is number of turns of the rotor into current flowing through the rotor. That will be give you MMF FF produced by the rotor. Is it okay? And the resultant air gap MMF is lower than the excitation or MMF provided by the rotor. It means from rotor side, the generator seems to be over excited. It means from our side rotor is, from our side generator is over excited. It means the resultant air gap field is lower than the field provided from our side. So you can say from our side generator is over excited. So this represent that generator is over excited. The excitation given to the generator on rotor is more than the resultant air gap flux. So you can say, sir, at zero power factor lag, armature reaction has directly demagnetizing effect and generator is said to be over excited. Is it okay? Now you can say, sir, in this particular case we observed that the total air gap flux will be lower than the flux provided onto the rotor. By providing current onto the rotor, number of turns are constant. So if you increase or decrease the rotor current, definitely the rotor field is going to change. At zero power factor lag, we found that the field provided by our side, that is from the rotor side, is higher than the resultant air gap field. This represents that from the rotor side, your generator is over excited. So from the field supply side, you can say the generator is over excited, and the effect is said to be demagnetizing effect. Is it okay? Now come to the armature reaction at zero power factor leading. Come to the third case, armature reaction at zero power factor leading. Zero power factor leading means the armature current is 90-degree leading to the armature voltage. Okay. Now please observe. Again, we have a stator, and in this stator A dash, B dash and C dash. I am taking the instant at which A phase induced EMF will be maximum. Now please observe, we have this to be the rotor. Now induced EMF in A phase is maximum when the rotor north is at this position, but the current flows in A phase will be maximum after 90-degree of the induced, before 90-degree of the induced EMF. So as the induced EMF is the function of rotation of the rotor, so it means when the rotor north is at this position, at that time the current will be started flowing in the conductors as the current flows under the influence of north pole. Is it okay? So, whenever your power factor is 0 lagging, it means you have to 0 leading, it means you have to provide opposite to the field, it means you have to provide a lag of 90 degree to the field. Automatically it is going to be satisfied, because it is not possible to represent the lag and lead in the current in terms of dot or cross. So, please observe here, at 0 power factor leading, the current start flowing in the conductor before this induced EMF, or 90 degree before this induced EMF. So, you can say, sir, when the pole position is this, when the pole position is this, then your current will start flowing, and this current flows under the influence of north, and this current will be maximum. Is it okay? So, you can say, sir, this will be your main field MMF FF, and if you observe, if the current flows in this fashion, then that will create an armature field. Again, if the armature field, if you observe, then armature field created by the current flowing into the armature is in this fashion by the right hand curl rule, and this suggests that this to be the stator north and this to be the rotor stator south. Most of the student ask, sir, why you have marked this as a stator north? That portion of the iron is said to be the north, which releases the flux into the air. It does not matter what is the shape of the magnet. Is it okay? So, that is why this is from this portion, magnetic line of forces are coming out into the air, and from this portion, magnetic line of forces are going into the air. That is why I have marked this to be the north and this to be the south. However, in case of rotor, if you observe rotor as an iron part, so in this iron part, flux lines are coming out from this portion and going into this portion. That is why I have marked this as a north and this as a south. Always remember that stator is observing the rotor. So, stator field is coming out in this fashion, while rotor is observing the stator. So, rotor north is supplying the magnetic line of forces towards the stator side. Is it okay? Now, you can say, because of the stator field can be represented as armature MMF. So, you can observe the armature MMF and field MMF both are in the same direction. So, overall magnetization is increases. You can say overall magnetization is increases. Both the magnets are seen to be the big magnet. So, you can say overall magnetization is increases. It means at 0 power factor leading, armature reaction has directly magnetizing effect, and the overall flux will be more than the applied field flux. Now, please observe here, if this will be your field MMF, then 90 degree to the field MMF is the induced EMF, that is I have representing by EF, that is induced EMF. Now, from this induced EMF EF, the current IA is 90 degree leading. So, this will be your IA, and armature MMF must be in phase with armature current, as number of turns of armature is a constant parameter. So, both the fields are in the same direction. Therefore, you can say, sir, the resultant magnetic field will be higher in magnitude. Now, if you observe, the resultant magnetic field is greater than the applied field flux, it means from our side the generator is said to be under excited. It means the resultant flux is more than the applied field flux. So, the generator is said to be under excited from the excitation point of view, under excited. You can say, sir, at 0 power factor, lead, armature reaction has directly magnetizing effect. And generator is said to be under excited. Is it okay? We can also see the other power factors like 0.8 power factor lag and 0.8 power factor lead. Let us discuss about that also. Okay, now let us see about the armature reaction in synchronous generator operating at 0.8 power factor load. Mostly RL type load are supplied. So, I am taking the consideration of 0.8 power factor load. So, armature reaction at 0.8 power factor load. This is your case number 4 at 0.8 power factor lag. So when I am saying 0.8 power factor lag, if we only represent the A phase, then you can say, sir, now I am only going to represent the A phase. Instead of representing all the phases, I am just representing A phase. Now please see, we have this as a alternator, stator and stator conductors as A and A dash, okay, and this will be your rotor. Now at 0.8 power factor lag, you can say when the north is at this position, induced EMF in A phase will be maximum, but the current flows when the north reaches to this point because the current is lagging the voltage. So you can say, sir, when the rotor north and south reaches to this position, then current flowing in A dash will going to be maximum. The induced EMF is maximum when the north is at this position, but the current flows when the north reaches to this position, because the induced EMF is a function of rotation, or you can say function of time. As fast as you rotate, the induced EMF polarity is going to be changed. The magnitude of the induced EMF is changing. So you can say the degree of rotation will represent the time displacement of the induced EMF, and you can say the time displacement of the current. In case of 0.8 power factor lagging, is current lags the voltage by 0.8 cos inverse 0.8, 36.86 degrees. So this current will start flowing at this particular instant of the rotor. Is it okay? Now you can say, sir, this will be your rotor field. Please observe, that is main field FF, and armature, because of the current flowing in armature, this will be your armature field. So you can say this will be your armature field FAR. So FAR and FF, if you found the resultant, then the phasor sum of these two is directed somewhere at this point. So you found that the resultant magnitude is lowered, as well as the position of the field is also changing. Is it okay? So you can say, sir, at 0.8 power factor lag, armature reaction has both cross magnetizing as well as demagnetizing effect. Is it okay? Now please observe here, that will be a more convenient way to find the armature reaction. Let FF be the reference. Reference can be drawn anywhere, okay. So let FF be the reference, then from FF, EF is 90 degree lagging, and IA is, I am saying internal power factor angle. IA lags EF by an angle of psi. That psi is called as internal power factor angle. So that is cos inverse 0.8. So if this is your IA, then in phase of IA we have armature MMF, and armature MMF and field MMF phasor sum will be can be represented here as F resultant. So if you observe, the resultant field is deviated from the main field axis, as well as you can say, sir, there will be a magnitude of resultant field is lowering down, because you can say, sir, this FAR can be resolved into two components to represent the shifting and magnitude to be lowering in case of 0.8 power factor lag. This component can be represented as FAR cross magnetizing component, that is responsible for shifting of resultant flux, cross magnetizing MMF, that is responsible for the shifting of the flux, and this is your FAR demagnetizing component of armature MMF, that is responsible for the lowering of the flux. So you can say at 0.8 power factor lag, armature reaction has both cross magnetizing and demagnetizing effect. At 0.8 power factor lag, armature reaction has both cross magnetizing and demagnetizing effect. Is it okay? One more thing, F resultant magnitude is lower than FF. So, it means from the field side it is over excited. So, that is over excited. So, whenever alternator operating at lagging power factor, the alternator is said to be over excited. Is it okay? One more thing, what is the angle difference between stator MMF and rotor MMF? So, you can say, sir, armature MMF lags field MMF by. Why I am saying lag? Because the phasors rotate in an anti-clockwise direction. So, first we will get FF, then F resultant, then you can say EF, and then IA, that is the phase of FAR. So, FAR lags FF by an angle of, this angle is 90 degree. So, you can say 90 plus psi, where psi is the internal power factor angle. Is it okay? You can say, sir, what is the load angle delta? So, load angle delta is this. So, you can say F resultant lags FF by an angle delta. So, what is delta? You can say delta in terms of, also you can say, sir, delta is 90 minus delta. You can say F resultant is the angle between F resultant and EF is 90 minus delta. Is it okay? Now, so keep these all angles in your mind. Okay. This is the case of 0.8 power factor lagging. We found that at lagging power factor, armature reaction has cross magnetizing and demagnetizing both effects, and the generator is said to be over excited generator. Now, observe for 0.8 power factor lead as a fifth case. At 0.8 power factor lead. At 0.8 power factor lead, again I am only representing the A phase. So, stator with the conductor as AA dash. Okay. In case of a single phase, you can say this AA dash is only present. In case of a three phase, all the phases are present. So, if you consider this AA dash and this to be the rotor. So, when the rotor north is at this position, then the induced EMF in A is maximum. But since the current is leading the induced EMF by an angle of cos inverse 0.8, it means when rotor is behind this by an angle of cos inverse 0.8, it means when the rotor position is this as a north and south, then the current flowing in AA dash is maximum, and the direction of current is as the magnitude in the direction of current is as the conductor under the influence of north carries when the field is rotating in a clockwise anti-clockwise direction. So, you can say this to be the outward and this to be the inward. Now, please observe, this will be your field axis, that is rotor MMF axis, and the current flowing into the armature is creating a field, and this is your armature MMF. In all the cases, I have represented the armature MMF at the same point, if you observe. So, this armature MMF and field MMF, if we take the phasor sum of these two, then the resultant MMF seems to be more than the field MMF. Is it okay? Now, it will be more better, it can be understood in a more better way, as you can take FF as a reference. So, if FF is taken as a reference, then induced EMF EF is 90 degree lagging to FF. Okay. And for 0.8 power factor leading, IA leads EF by an angle of psi, that is internal power factor angle. In phase of IA, we have FAR, because armature MMF is N into IA. So, you can say, sir, it is in phase with IA. FAR and FF will give the resultant field F resultant. So, you can observe the F resultant is more than the FF, but it always lags FF. That is the compulsory thing, because the generator can only generate when rotor north try to align towards the stator south, and you are providing motion against this electromagnetic torque. Is it okay? So, in case of generator, always the rotor field is ahead from the stator field, and that is why we always say that the power always flows from higher load angle to lower load angle. Is it okay? So, you can say this to be the load angle delta, this is your 90 degree. You can observe here the resultant flux is more in magnitude, as well as the position of the resultant flux is shifted. That can be understood by resolving the FAR in two components. FAR, this component that is along the horizontal axis is responsible for cross magnetizing effect, and this portion is said to be FAR magnetizing. So, due to FAR magnetizing, magnitude of the resultant flux is more, and this is due to the FAR cross magnetizing, the position of the resultant flux is shifted. So, you can say F resultant is more than the FF. It means from our side the field provided is lower than the resultant air gap field. So, from the excitation side you can say the generator is said to be under excited. Is it okay? So, in this case the generator is said to be under excited. So, always remember, whenever your generator is operating at leading power factor load, the generator is said to be under excited. Is it okay? Now, you can say, sir, at 0.8 power factor lead, armature reaction has both cross magnetizing and magnetizing effect. F resultant magnitude is more than FF, so the generator is said to be under excited. Okay, and you can say, sir, if we observe here, then FAR lags FF by. If you observe here, the FAR lags FF by. So, FAR is here, FF is this, the total angle is 90. So, this angle is 90 minus psi. So, you can say, sir, FAR lags FF, it means stator MMF lags rotor MMF by an angle of 90 minus psi, where psi is the internal power factor angle, and the angle between FAR and F resultant and FF. So, you can say F resultant lags FF by an angle delta called as load angle. Is it okay? Because if you increase the load, armature current increases. With the increase in armature current, you can see that this flux is going to be directed here, and as the load angle delta is increasing, that representing with the increase in load angle is increasing. Is it okay? So, you can say, sir, this to be the F resultant lags FF by an angle of delta, that is load angle. Is it okay? So, keep these angles in your mind. Now, I try to construct a electrical equivalent model of this synchronous machine, because once we have the electrical equivalent model, then we can predict the entire performance of the machine at any operating condition, and this is the main concern. We can't just design and put the we can't just design and use the generator, because we don't know what is the behavior of the generator under the different loading conditions. So, we have to analyze what load we are going to use, whether the generator is capable to deliver that load or not. So, all these conditions we must have to understand, and this analysis is called as electrical analysis. So, since here we have two domains, one is your mechanical domain, magnetic domain and electrical domain. So, you can say total 3 domains. So, all of 3 domains are now going to be converted into a single electric domain. So, the analysis will be simpler, and that is what we call electrical equivalent model of synchronous machine. So, the next topic we are going towards the electrical equivalent model of synchronous machine from the MMF and armature reaction analysis. Is it okay?